that, let me exit the student preview, discard whatever we had, and close. Let that be actually, I'm going to need it later on. I will go to the notes. So you will see I'm not in a habit of reading stuff over here. I'm just going to go through it, and we'll go through all the stuff we need to kind of know to start everything. And if there is anything over here that is something to be added to OOP244 knowledge for our knowledges for starting of OOP345, I will talk about it. So we said the review from whatever we had. Object orientation is essentially putting the three things together in an application: encapsulation, inheritance, and polymorphism. And our friend over here is going to tell us what is encapsulation. Sorry. What is polymorphism? Oh, if you don't know the rule, when you get the microphone, if you're not in a mood of talking yourself, you simply say pass to the next person. If you hear the pass 3 times, then you can take over. Okay? Go ahead. And you can give me interview answer. So when I ask you this question, assume I want to hire you. A very normal response when a student answers you. When you go for an interview, they're not hiring you from C++, even if you're advertising it's C++. They need to know if you understand the concept. So if you want to set the coding aside and tell me what is polymorphism, what do you think polymorphism is?
I think polymorphism is something that allows different objects of different classes treated like object of superclass.
You are almost there, but can you, again, one small sentence. Polymorphism is? Okay.
Using the same name for a function, but adding something to it?
See, again, you're giving me a code. You're giving me function. So the answer for it is doing the same thing in different ways. That's all. What is polymorphism? Doing the same action in different ways. Poly, many, morph, change. You don't need to go deeper than that. Because it's many different shapes. When you're saying different things, that's not the case. Is polymorphism. Overloading is polymorphism. Casting is polymorphism. So there are many different examples for it. Never go with example, give the idea. You can pass the microphone to the lady over there. We're good down to this point? All right? So polymorphism, doing the same thing in many different ways. Pigeon flies, helicopter flies, kite flies, and airplane flies. They all fly. They are all flying objects doing the flying in different ways. We good? Right? Choose encapsulation or inheritance. Which one you want to talk about?
Inheritance.
Encapsulation?
Inheritance.
Inheritance? Go.
Yeah. It's where like you have one class and you have another class that takes the data or the structure of the previous class.
Okay. So it's one class and there is another class taking the structure and data of the first class, right? Again, example from the code. Okay? Perfectly good. Nothing. And another thing I wanted to ask you, use your opera voice. If you go to an interview and somebody asks you a question and you tell them, okay, so use your opera voice.
Basically, like one class inherits to another class, and it's like child class and parent class.
Beautiful. So again, examples. Okay, pass it through. Okay, so the correct answer for it is to reusing design. Inheritance is to reuse an already existing design. That's inheritance. When you think about it, you design a class, you design a vehicle. A vehicle's job is to carry things around. Now, you use the design of a vehicle and you extract a car out of it. So car, a vehicle. What is that beep? Car, a vehicle. What do you fill the beep with? Car, blank, a vehicle. 2 letters, INS, is. Okay, is. So when you have is a or is am, you always have inheritance. Remember that. Or if you want to be specific, is a kind of, okay? Design. The way we use code. In structured programming, we wrote functions, we recalled functions. That's how we reused codes, right? In inheritance, you create the entire class with all its capabilities and algorithms and properties and everything, and you get that class and you build a new class out of it. So the new class has all the capabilities of the previous class plus whatever you have. Are we good? Are we okay? All right, so that's inheritance, reusing design. Okay, reusing design. And what remains is encapsulation. Actually, we should have started with encapsulation. What encapsulation is?
When you put together the data and the logic to make methods.
That's it. You're done. You don't need to explain. When you pack data and logic together, okay? Data and logic. Data and behavior, attributes and behavior. When you put them together, you have encapsulation. Encapsulation has a beautiful side effect. It's a very difficult question. What is the most meaning to encapsulation? Because in structured programming, we have data in some structure somewhere, and then we have functions, and we pass the data to functions, and we pretend things are happening. It's as if I have a booth over here, and nobody's capable of talking in this class. Whoever wants to talk, they have to go to the booth, and then they're capable to talk. They go out, and they can't talk anymore. That's structured programming. But in an object-oriented program, each object capable of talking just talks. It carries the behavior with it. Okay? That is data and behavior together. But one important side effect of encapsulation is, and I know that you're going to, let's see if you can do it. The most important side effect of it.
How it modularizes everything?
That's structured programming. Just put it in the header file and thing you modularize. That's actually, I think, yeah, the first thing that you have done in OOP345, right? Everybody think. What is the most important? There are two. Actually, encapsulation. Pardon me? What? Oh, the question is that, what is the most important side effect of encapsulation? Remember? Privacy. It enforces privacy. Thank you very much. You can pass it to the next person. It enforces privacy. How does it enforce privacy? I explained it in OOP345. I said, I'm going to go get coffee. You are behind me in the line. I forgot my wallet. I want to pay for the coffee. I forgot my wallet. I'm going to ask you, as my student, can I borrow $1.50 to get a coffee? You're my student. I'm your teacher. You're hoping that that's going to be good for you. You give me the $1.50. Most likely if you have it, right? Maybe even buy it for me, right? And I'll get it, and we're happy. We go. Scenario number 2, I go to the lineup, I want my coffee, I put it in my wallet, I put my hand in your pocket to make $1.50. And that's what it other name for the privacy, the buzzword that you have to give into the in the interviews is called information hiding. Information hiding. It hides information. Not only it hides information, but it hides action. How many of you guys drive a car? Only 2 people? 3 people? How many of you know how to drive a car? Okay, fantastic, good, beautiful. If you want the car to go faster, what do you do? If you want the car to stop, what do you do? Do you know how they work? If you know about mechanics, you know. But you know how it works, right? Most of you don't know how it works. And if you tell me you do, you're lying through your teeth. Okay? I've been a mechanic, so I know exactly how it works. But what I'm saying is that without knowing, you're using it. So any of you, when you're pressing the gas, if you are riding an ICE car, you actually go open a hood, hold the handle of the carburetor, or if it's an electric car, you gas pedal. Methods inside the car who's making the car do what it does, it's not even visible to you. That's information hiding. And I'm sorry, I have to, yeah. I keep forgetting to turn off my cell phone. And it's kind of, it is somewhere I know because, oh, yeah. Please turn it off. Turn off your cell phones. How do you turn it off? Okay, there you go. Thank you. All right. So that's that. So information hiding. So that's one of the most important things about, the 3 most important things about object orientation. And we need one feature in our program. We need, oh, you have it already. We need one more feature in our program to actually put all these 3 things together. They call it something very, yeah. So to make it object-oriented. So if you have polymorphism in your program, if you inherited one class to another, and if you put in some you have object-oriented program in, no, one word, no. You are going through code, not code. It's actually, and word, I love that word. When they work in, you can pass it to the gentleman beside you. You remember what it is? It works in harmony. It works in synergy. So synergy is the technical name for it. So you need, what is synergy? Anybody knows what's the meaning of synergy? Anyone? You have the microphone. You have the floor, my friend. You don't need to ask. You can just say.
It's when like 2 or more things are working together to create an end goal. Yeah.
Yeah, so that's it. So you have to put these things together so they work together properly, and that becomes object orientation. Now, do we understand what object orientation is? Hopefully? Okay, so all the things you have done in OOP345 was to be able to put these things together, okay, and make this thing work, and that's that. The class ends at 5:05, right? So we need to start our quiz at 5:05. Give it, say, 30 minutes. I wanted to have 2 questions. I put 1 question. Maybe 1 would be enough. Around 4:30. How much time do I have? I have half an hour. All right. Okay. The reason that I want to do it today and not the next lab is that I want to know it as soon as possible. One thing I have to tell you that I am sad about it every single semester is that students don't come to me when they have trouble at the beginning of the semester. They come after the study break and say, what can I do? How can I study to pass the subject when it's too late? If you need help, this is the time. Okay, that's why I want to kind of see who needs help, so I can send you a message, tell you, hey, you need to do something. Okay, so if you see there is any trouble in studying, please contact me and talk to me, so I can give you some ideas. All right. Actually, it's easier to do this. Please go read this. Again, as I told you, I teach 20% of what you see in these things, okay? And the other 80% is your responsibility. I kind of like those old cars that wouldn't run. You have to push them, and then they run and go. That's what I'm doing. I'm pushing you. And then you study it, then you come back the next day, and I say, any questions? You're going to tell me about that 80% that I didn't teach, that you didn't understand, so I can explain, okay? So these things, I don't want to tell you what are values, objects. You please go through it and read and see what it is. Okay, declaration and definition. Declaration is essentially introduction of things to say things exist, okay? And compiler trusts you, even if they don't. Compiler trusts you. So if you are compiling a code and you just make a promise that such thing exists, compiler compiles and saves not the executable, but the object code, the assembly code out of your C++ into your application, into your hard drive. What checks to see if your promises are actually kept is called linker. We'll come to it soon. Okay? We have local scope, we have class scope, and we have namespace scope and global scope. We'll go through it. Give me a second. Let me bring up the examples over here. Oh, so first of all, IO stream. Using namespaces, namespace std, int main, return 0. Always program like this. Complete the block, then fill in the blanks. Always. If you're writing an if statement, you do that, then you fill in the blanks. Okay, no matter what type of editor you're working with. Please don't open the curly bracket, keep going, and then you forget what you close where. Okay, so cout 02 January 10th. Hello, OOP345NAA. Right? Who has the microphone? Okay, what is polymorphic in this? Just out of curiosity, I want to see if you can identify it. What is polymorphic in this code? Based on my thing, what action in here has one shape? It's been executed the same way but does different things. No, both of you, but not cout is wrong. Insertion operator, thank you. Although it wasn't your turn, the lady had the microphone. Remember, 3 passes and then you talk. What? May I have the microphone? Thank you. So next one is you. All right, are we good? Okay, so it's the insertion operator that is polymorphic. Okay? Yeah. Just wanted to check. Let me see if it works. Believe me, sometimes even that doesn't work. Okay. Yeah, this is the insertion operator, by the way. Okay, so I could actually do this. I could say January 10. That's better. So this is really showing that this is polymorphic because it's showing an integer and strings and new line and yeah. Okay, so we're good? All right. So I save this. I'm going to say, all right over here, hello.cpp, and that's how we know things are progressing, okay? So the next one is going to be here, and I'm going to write the second code over here. And we're going to continue and keep going. So all right. First thing first, let's add existing item, which is going to be this one and this one. Talking about scopes. Whoops, not that one. What do we mean when we say scope? So remember, prg.cpp is always the last thing I talked about in class. Okay, remember that. Okay, what is scope? Scope is the range in which a variable is visible. Okay, all right? The range in which the variable is visible, not necessarily when it starts and dies. Okay, so now in here, as you see, Mark and I, they both have function scope. Okay, block scope, which means they come to life in a block and they die in the block. Okay, and remember, you can start a block at any moment of time if you want. If I wanted to do something temporarily and I didn't know what type of variables, let's say this is like 300 lines of code, and I want to write little thing to do something before I go, and I don't know which variables are installed throughout the thing, I can just write over here, write something like open a block without anything. Oh, this now it looks like it's for if. Not for if, but anywhere. I can go here and I write a block like that and start doing things in here. This is a scope. This is a block. Okay, it doesn't have any owner, it's just a block. So if you create an integer over here, if you create an integer at line 11, it dies at line 12. We got it? It doesn't have to be after an if. Okay, blocks can be anywhere if you want to. Okay, maybe I've seen this twice in my life. You can. Okay, I've never seen any type of literature that tells that don't do that, but I've never seen it done. Okay, so that's out of experience. And shadowing happens all the time, which means when you have an inner scope in any way, and you have the same name of variable created, it shadows the other one. It happens anywhere. So if you have an attribute in a class with certain name, and you use the exact same name inside the method of the class, that's still an inner scope, which means the attribute will be shadowed. So remember, shadowing happens all the time. You got to be careful about it. That's why creating variables like this sometimes confusing. You have to make sure that that's not going to happen. As you see, this is including a module. And in this module is using minimum passing grade, whereas the variable that is not declared over here. Obviously, that's what we call a global variable. A global variable doesn't exist on its own. A global variable is first created as a file scope variable. And then it will have a declaration inside the header file. That declaration makes the file scope variable a global variable. So if I look at my module.cpp in here, you will see that I have two file scope variables, but one of them is global. Okay? The max student number length, that's file scope within this one. But the minimum passing grade that is 50 over there, it's global. How did I make it global? I put a declaration for it in the header file. How do you put a declaration for an object, not a function? Using extern. So you put the type and everything of the variable or object or whatever you have, constant int minimum pass grade, and you put an extern in front of it. Okay? That makes the variable that is defined in a file accessible to whoever includes the header file. Capisce? Are we good? Yes. Pardon me? Wait for it. Okay. You want to say the same thing? What is volatile? Okay, we'll come. Relax. I want to ask the question from the gentleman. If you've been using OOP345, two very famous objects that are global and they have an extern, what are those two? There are two instances of, if you don't know, you can say pass and give it to the friend in front of you. What? Main? No, that's a type. That's defined in the grammar of the language. That's not, there's no extern for int. And it's OOP345 that it's, in C++ we have two important things that we are using all the time. Remember? No? C in and C out. These are two objects of type OStream and iStream, created in iostream.cpp, let's call it. And in the header file, they are extern, so you can use them anywhere. Anywhere you use the thing, you include iostream, you can use C in and C out, the objects. Okay, that's one of the most important, like one of the most famous objects that they have externs in them. Okay, are we good? Are we okay? That's linkage is that extern thingy. So please go through it and read it. Compilers. Those who've been in OOP345 class of mine and even IPC 144 class of mine have seen this already, but I'm going to explain it over here so we can all share it, which is how compilers work. So this is a diagram that actually tells you how compilers work. And this is me trying to log into this. Okay. Yeah. So, anybody over here have problem with colors? We're all good? Okay. I may refer to blue, red, green, and brown, but just in case if anybody have a problem with it, let me know. Okay? So, in the case you see over here, I actually have 4 files that I'm compiling. 1.cpp, 2.cpp, 3.cpp, and 4.cpp. Okay? So what you see over here is actually, oh, can I actually do this? I've never used this over here. What does it do? I thought, okay, anyways. So it's actually something like this. Let me take that out. And put it over here. And up here, I'm going to write what that means. So what you had over there on a Linux computer, it is G++, 1.cpp, CPP, 2.cpp, 3.cpp, and 4.cpp, enter. That line causes what you see down here to happen. Okay? So, when you issue a command like that, okay, 5 executions happen. So if you compile 1 file, 2 executions happens. If you compile 2 files, 3 executions, always 1 more. Okay? So the 5 executions are that 4 times the compiler is going to get executed separately without knowing that the other one is actually running. 4 separate times. It's as if separately you called G++ 4 times. And then the 5th one, linker, will be called. Okay? So when the first one is calling, it compiles 1.cpp with the header file included and checks for all the promises made in the header file. And if everything's good and declarations are correct and everything's what? Nice, the object file is getting created out of it. Then 2.cpp with the header file, same thing. Then 3.cpp is called. 3.cpp not only have its header file, but because the programmer had to, they included the 2.cpp's 2.h in the 3.h, okay? Because they're using functionalities of 2.cpp. So when it's getting compiled, as you see, what is getting compiled over here is essentially, this. You follow? Okay? The 2.cpp is not involved over here. It's only the promises that are compiled. It runs the compilation, and 3.cpp has some function calls from 2.cpp. It trusts that it exists. It translates the function call. It is not happening. It's just translating the function call to machine language. And this is created. And then 4.cpp is called. Now 4.cpp is called. What happens over here is this. So essentially this is what is being compiled. But if you pay close attention, you will see that 2.cpp, 2.header file, without the programmer knowing, is compiled twice. And that's why you have to have safety guards, compilation safeguards in your header file at all times. You know how to do it. I'm not going to repeat it. We follow the exact same rules of OOP345. Okay? So because of this fact, that happens. We have to have that. Now, all these things happened. We have 4 object files over here. So it's as if you are talking to me and you say, I need help, and I'm going to say down in the learning comes over there, there is actually a tutor that's going to help you with this matter. You're not going to give me any compiler error. This is when we are compiling your problem. You would say, 2 thumbs up. Thank you. I'm happy, you're happy, everything's good. Then you go over there and you see there is no 1. I just made an empty promise. That's your linker being called. So linker is actually you going and trying to see if actually there is anybody over there to help you. That's what linker does. Linker links all these things together, makes sure all the extern variables exist, all the functions and classes and stuff that you promised, their source code exists, and everything in these 4, and it links them all together. Okay? Or it checks to see if you have 2 copies of the same thing by mistake. 1 definition rule. You cannot have 2 definitions for one thing. You cannot have two integer global variables with 2 double variables with name pi, and you extern it in a header file. Then it says, hey, you're saying there's an extern variable called pi, but I have 2 of them. Which one is the one you're talking about? Okay? We're good down to this point? So that's what linker is doing, and it compiles, and if everything's good, the executable is created successfully. That's when you run it, and you find out that you programmed wrong. You have to go back and do everything from the beginning. That's how compiler works. Are we good? Questions? Suggestions? Objections? We're good? All right, all right, all right, all right. Okay, good. So let's, okay, so clear all and stop drawing, and then down. Let me take this away so it's not in front of our face. So that's that. So function scope, file scope. So these are all the things that we have in here. Please go through them. Compile time, we went through. Statically and dynamically allocated memory. Statically allocated, this doesn't mean the type static that we're going to talk about soon. Okay? What is a static type? It's not that. Statically allocated memory is a memory that you define in your application, and it's within your executable. Essentially, every variable, every array, normal array that you create, all these things are inside your executable, okay? So what happens is that, but dynamic ones are the ones that you allocate using dynamic memory allocation, and the memory that you are using in dynamic memory allocation is not in the executable, but it is in the, you remember? Somebody go for a surgery of it. Not heap, but okay, heap. Okay, it's any heap. Essentially, is a memory. Keep it. You're going to answer there. It is on. It's always on. Is it on? Who turned it off? So all those people who did that, it's nothing got recorded. Okay, mine is on you. And if you see that this thing is blinking or that is blinking, let me know. Okay, so we're good down to this point. All right. So code segment, data segment, stack segment, heap section. Okay, code segment is when you create a literal value in a thing. You write A is equal to 4. What is that for? 4 that you wrote. You write 4. You write 25 in your code. If this thing is less than, what is that 25? That's where it resides in your code. That's in your code. Variables in the stack segment. Data segments are data that are outside of your executable and you're accessing them. So peripherals and things like that. There are segments that, like you're accessing a file or something like that. So these are, and dynamic ones are the ones that we said you dynamically allocate. Yeah. Okay. Talked about the scope, we talked about it, block scope, yada, yada, yada. Go through it, we talked about it. Linkage, we talked about it. Internal type. Volatile. Okay. First, when you don't say anything, it's just an automatic variable with the lifetime of its scope and so on and so forth, right? When you're saying const, it means it is a constant value. And its constantness, it's a constant value that can't change. We have two different types of const. When we go a few weeks later, I'll explain what's the difference. We have consts that you can find their values when the program is being compiled. Okay, at compile time, they become const. There are consts that when you execute them, they become const. They're two different ones, okay? We'll see, or we'll talk about it soon. But for now, it's only one. Just keep it in mind. Because people are going to ask, the class actually said, what is constant expression? I'm like, wait for it. We'll talk about it. Types of memory. We have a lake, we have a barrel, we have a bucket, we have a cup. Lake, barrel, bucket, cup. Which one you can hold it in your hand, or a bottle, let's say. Which one you can hold it in your hand and run? Bottle. Okay, with bucket you can walk. With barrel, you have to put it on a dolly and you're going to go very slowly. Lake, you just look at it. You can take stuff out of it, but you can't move it, right? So lake is the hard drive, is the big thingy that you have, ginormous stuff that you have, right? Barrel becomes essentially the memory, RAM that you have. And you take stuff from your hard drive and put it in RAM. The bucket that you see over there, the bucket that you see, that's the buffer. Buffer of CPU. CPU has a buffer. What is a CPU? Do you know what it stands for? All these stuff you have, right? So it needs to get stuff from RAM and process it. It cannot always carry the barrel around. It takes the information a bucket at a time, changes it, and then puts the bucket back in a barrel, then takes another bucket, and keep doing that over and over. That's buffering. It makes the work faster. But there is that cup. Do you know what, actually give it back. Do you know what a register is? Register. Okay, so your CPU has 32 word size memory. When I say 32, I don't mean 32K. I don't mean 32 megs. 1, 2, 3, 4, 5, 32. Each one is to the size of the bit of your CPU. So when you hear a 64-bit CPU, the length of a register is 64 bits. Okay? And it has, depending on what is the CPU, it used to be 16. There are 32 ones and 64 ones. So that's it. Like that's the number. Okay, so each core of your CPU has those. Computer. Car is driving your, I don't know, AI is answering your questions. All these things happen in those registers. See how fast they are, because they are in the belly of the core of the CPU. Okay? Now, if you have something in that barrel and you want to change it, you have to put it in a bucket. From bucket, you put it in a register, you process, and you put it back, right? If you want to change something in a bucket, in a barrel, it's much easier to bring a bucket and then keep going back and forth between the register, between the cup and the bucket, and do changing, right? And at the end, you put the bucket back. Sometimes what you have in a barrel, it's important, and someone else with some other bucket and a cup may add stuff to it, which means the barrel may change while you are doing something in here. Because of that, sometimes for every single action, you want to go back to the barrel. You want to make sure that every single change that you are making, it is done to the barrel. Example, you are writing a program that is supposed to receive information from a network card. If you get the information from the network card and start doing it, it might have changed. New information will be in there. You don't want that. You want, if something is changed, it's changed at the target. Obviously, it's very slow, but you need to do that. You want your variable not to be cached or buffered at all. And whatever you do is changed at the location you designated for it, you make it a volatile. Does that make sense? So if you say volatile integer I, it means every time I'm adding 1, I want RAM in my computer to change to 1, not only in your register. I don't want you to make it efficient. If I'm adding 30 things to 1, and you see there is no need, I can do all of it at the same time, then to put the final result back. You cannot make that update or efficiency to the code. You tell it's volatile, which means any change I do, don't optimize it. Change the target. Now, that could be read-only or read-write. That's volatile and constant volatile. You're not going to use it in 345. Just know that when the time comes, and you're working with Google and you're doing something, probably we're not going to write anything easily. But you need to know it. Please go through the namespaces and see if there's any question. Let me know. Using declaration, please never, ever, ever, ever do using in a header file. Okay, I don't know if they told you in OOP345 or not. You are not allowed to write using namespace yada yada inside a header file, because it means anybody who includes that header file is going to use the namespace without knowing. And suddenly a huge scope of variables and names becomes open to its code without knowing. So use it when you are when you need to use a namespace inside the header file, always qualify it. If you want to pass an instance of OStream, don't write using namespace std. You have to write std scope resolution OStream in the header file. Got it? Extremely important. Anonymous namespaces, read it. Anonymous namespace is essentially the block that we have in the code. I said you can have a nameless block to create something in it. You can do the same thing with a namespace. Okay, please go through it, read it. If it doesn't make sense, let me know. And good design practice is exactly what I told you. Lifetimes. Lifetimes of objects in C++ falls into 4 categories. Okay? Category 1. Number 2, static. Anything, its lifetime becomes global, but the scope of visibility remains the same. So if inside a function you make an integer static and you initialize it to 55, when the function runs for the first time, it becomes 55. And whatever comes back to it, the next time comes, it's going to be that value. The value remains the same. It keeps its value. It will never get changed. So the initialization, that is assignment at the moment of creation, only happens once. And it keeps all its values. We'll find out how it works later on. Dynamic, you already know. You dealt with it many, many times when you forgot to delete something. The lifetime of a dynamic reallocated memory is completely in your hands. If you don't deallocate it, even after your application is gone, it's still there as memory leak, right? So you decide when it dies. Are we okay? Threads. We're going to learn at the end of the semester. How many cores, anybody knows how many cores there's? This CPU here has cores. What does it mean? Advanced. The pulses of electricity that does it can go up to certain speed. It cannot go more than that. We are at the top of the speed that we can. We cannot make it faster. So what do? We add to the number of processes. It's like, I want this place to get clean. You bring one person and cleans it up, okay? That's fine. Okay? But a person can clean up this room with a maximum speed of a certain thing. They cannot go faster than certain thing. But I have 1, 2, 3, 4, 5, 6 rows over here. If I bring 6 people over here, and each person with the maximum speed clean up the row of their own, the room is going to get cleaned 6 times more, correct? That's called multi-threading. You're going to learn how to do that at the end of the semester. You write one function, and you make that function run 6 times parallel to do something faster. Now you define the variable in there. What happens to that variable? That variable is a thread local, which means each instance of the function that is running parallel. There's one thing over here, compilation stuff. I talked about it. You know exactly what it is. You see this over here. The compiler that you're using on Matrix, because the compiler that we have comes with the operating system, and Linux is highly tied to its compiler, which means any update that comes, it gets recompiled and it gets upgraded like that. They cannot upgrade the compiler, C++ compiler, inside Linux. So that's why when you did programming with 244, you just say G++ and life is beautiful. I think it's C++ 11 or 14, okay? We are using 17, so they installed it in a separate directory, and to run your programs properly, you have to run this big thing over here. You have to export that and run this thing so it actually compiles it. Now, go Google it. ChatGPT it, how to create an alias. Create an alias with this thing, for this thing, okay? And for this part, and call it G++ with a capital G. So when you type G++ with capital G, it becomes T. Export in dot profile. If you don't know what dot profile is, bash profile. If you don't know what it is, okay? Every single time you compile, you have to do this. My submitter knows what it is. So it's going to compile it like this. Don't worry. Okay, but yeah. That's that. Remind me of talking about the arguments of main the next time you're coming in. Okay? So the next time you are one topic behind the other class. That is the main. Okay? Okay, we'll come to that. So the next time you're coming in, you make sure somebody remind me, Farda, talk about this real syntax of main. Real syntax of main. Okay? So get your computers, please. We have to do that one question. I cannot add another one. Start Notepad++. Start Notepad++, and I'll tell you what the code is for the test. Do your best. Try to write it as clean as possible. Write your answers in Notepad++ and paste it. If your screen is small and you see the question is very small, put the mouse over there, hold the control, slowly dial up on the wheel, and it becomes big. So that sidebar goes away. How much time am I giving for this? Let me see what is the duration is. Oh, I don't have a duration. Where's my, hurry up. So under quizzes, it's OOP345 assessment test. Let me just first set up the time for it. So I'll give you 30 minutes to do this. Where is time? Seriously? Pardon me? Oh, sure, let's do that. Okay. I just want to make sure that, anyways, sure, I'll do that. So the access code for it is, 678 299. 678-299. Do the best you can. And implement that little program over there and paste it, as I mentioned how to, at the top of the test. I would really appreciate it. Yeah, so you have 33 minutes. If you have any questions, clarification, let me know, and I'll come to you. Everything is done in one file. You don't need to include a header file for double list or anything like that. You are just writing one class for me. It's not a module. Just one class, and that's it. I'm looking at what people do, and I'm going to give you feedback on it as we go through it. I'm going to call your name, and please let me know who you are, okay? K-S-E-O-Y. That's your username. Starts with K-S-E-O-Y. Okay. Let me maximize it. Give me a second. Maximize. That's it. Okay. And my apps, you have to start. Notepad++. That's it. Notepad. That's fine. That's good. There you go. So you put this one. Save as. Write something.cpp. .cpp. C. There we go. So that goes to right, and this comes to left, and start doing it. For me, what's important is logic. Please don't try to be perfectly correct. And it's not an open book thingy. I didn't pack your stuff, so don't use your stuff. Use your knowledge. Don't shoot yourself in the foot. You really want to know. JAHN28. JAHN28. All right. Save the file under the extension .cpp. Save the file under the extension .cpp. Good file. Save as. And right over here, whatever .cpp. There we go. Not even and listens and things like that. Okay. And please keep it simple. Yeah, good job. Yeah, save as. That's right. Yeah, go. You're doing it. .cpp. Perfect. PP. Save. Good. We don't need a main. I never asked for a main, just a class. It's a class, it's not a main. I'm not asking you to write an application. Design a class only. Sorry, I'm talking too much, and just quickly give feedback. Capellan, Capellan, TKAP. Yeah, save it under .cpp, please. Save the file with .cpp extension, please. File, save as. No, not there. File. Something.cpp, doesn't matter, whatever it is. Just rename it. You don't need to go anywhere. Just right there. Oh, sorry. I think it was me. Now it's okay, because, yeah. There we go. Thank you. Sorry, my mouse was on your screen, that's why. Perfect. Oh, save.